Hi guys, welcome to my YouTube channel. Today I will going to teach you how to make another data science project on the topic crop yield predictions. The aim of this notebook is to predict the crop yield using the data from the given data set. The data set will be looking as like this. It has the data dictionary as column, says rainfall in the millimeters, then the temperature in Celsius, fertilizer in kgs, nitrogen in macronutrients, and phosphorus macronutrient, potassium as macronutrient, and red yards acres per. Then for the not wasting time, I have already imported the modules that is required right here as Pandas, NumPy, Matplotlib, plot as this, and the Seaborn for the key EDA. Then we start the key data pre-processing part. Okay. First of all, we will going to check the first 5 entries from the key data sets from the key. Okay. This sheet X, like let's run it to see how it is looking. Wait a second. Yes, right here you can see it has taken a little longer than the expected one. Okay, so let me open up my terminal so that we can see the key variables right here, which will be coming sooner. Then we will going to check its data shape of the data set. Okay, wait a second. Okay, right here it has came to end. Then it has show the data entries shape of the data set, as it will going to has the 7 column and the 9 entry like stuff. And then we will going to check the data set types of it. Let's run it to see it. Right here we can see rainfall in the font, fertilizer as this, temperature as object, nitrogen as a font, then a again font, and the font data type as object. Let's see what type we have in the temperature, which is converting it into object, and we will convert it to the float type to for the further easier classifications of it. So we will check the what is unique part. So right here you can see it has given us an error of it as temperature as appearing 28 normal font values right here, and the like null value and different different value, which is demonstrating its different stuff font, which is not should be present, so we have to drop it. So then we will going to drop it by writing the method as the df is equal to df bracket df bracket temperature not equal to, okay, double dot once. Okay, then we will going to go ahead. Then okay, we will going to convert the temperature column into the float side, right, by doing this command, and it will execute it. Then we will going to check the key if the any part of this dataset part has the null value or not. Okay, then right here let's run it. Now we can see it has the key remaining none values, like everywhere it has a 999. Okay, so we have to replace this missing value with median of the column. So we will going to take the key with the median as a key. We will going to define the its columns equal to dev columns. Then we will going to go for the for loop of it in columns. Then we will define the dev key index of that column, dev index fill now dev column dot median of it. Then we go to its statistics parts. Okay, descriptive statistics. In this we will going to take its values as count, mean, standard deviation, minimum value, 25% of its value, 50%, 75%, and maxima and minimum, like stuff. So right here it has come here again. You can see, like you can see the count as the everywhere as 1999. Okay, then the mean of its value as rainfall in the millimeter as this, as its total data set would be around 500 something. I doesn't remember it right now. And temperature as T2, which is the normal and basics according to it, and the nitrogen concentration, phosphorus, and potassium, and real per acre, and its standard deviations, as you can right here see, and its minima or minimum values as right here 400, 50, 24, 59, and so on. Then the 25, which is 50, and maximum values of it. Okay, like in the monsoon season, like we can have this kind of minimum maximum values, right? So let's go to our exploratory data analysis part. First of all, we will going to go to the rain distribution part. For this we have taken the histograph. We will going to take the command as okay, cbon dot histoplot bracket x comma x equal to rainfall millimeter, data will be df, and kda is equal to true. Okay, then we will going to examine its part. Okay, right now it is forming the graph by analyzing it. This thing takes a little while time. So okay, right here you can see it, like in the for the 400, right here you can see 400 millimeter, right here to the 50, then the lower of it according to the season and counts, and then the minimum, and then this. Okay, in the above histogram we can see the distribution of this, and the graph reveals the rainfall is not fully normally distributed, either the rainfall is above 400 or 500 ml, or it is above 1100 millimeter, like you can see right here, like it is showing its difference, like it requires the different type of crops like rabi or krabi difference. Right here you can see it is showing a sign of it. Then we will take its fertilizer distribution similarly like before we have done. Right here we will going to take the fertilizer part. Okay, now let's run it and see how it's going to see as. Okay, right here it has come as the count and fertilizers. So we can see it's the this graph shows the distribution of the fertilizer for the crop. In this graph we can see there are two divisions in the uses of fertilizer. One is lesser than 65 and other is above 65. Fertilizer has a huge impact on the crop field, therefore we can assume relationship between the fertilizer and the crop yield, like in the different crops we required, like in the pulses or rices, like rices required higher water stuff, like you can see water like rice like crops. Okay, rice and wheats. Then we will going to check its temperature distribution. Okay, similarly like before we have done it right here. Okay, then you can see its crop as showing also similar like the before two graphs, which hits the data set is between the either 25 to 30 or 35 to 40. This indicate the rabi or croppy crops in the data sets like I have tell you before. So let's go to the is micronutrients part. So we will going to take its figure in the same form histograph. So we will define the figure, and axis is equal to plot subplots bracket 1 comma 3 figure size 10 x y 5, sorry, and then the histograph of nitrogen with the axis equal to 0, then the histograph of phosphorus, then the histograph of potassium. Okay, then we will going to go ahead. Okay, I forgot to do it. Okay, right now it is starting. Okay, right here you can see its data sets are coming like the figure of this and this. Okay, like these kind of graphs like which we have taken right now, we can add it in the analysis part of it or reports. Like we can create the result folder right here or analysis folder, in which we'll be going to create a MD part of it, which will going to store all of its graphical representation. Like right now let's resume it and review the graphs. As in the nitrogen part we can see it has been going either the 65 60 65 or 70 or 75 or 80, and the similar way the potassium test. These are the basically the graph looking closer to the basically Rabi and Krabi crops. More indication towards it. So let's read the below description for your reference. These three graphs show the distribution of the micronutrients used in the crop. From the graph for nitrogen, we can see that the larger quantity of the nitrogen is used in the crop. The graph for phosphorus shows the uses of lesser than the nitrogen, and the uses of potassium is way lesser than the nitrogen and phosphorus, but still it has the two peaks. This could indicate the dataset has been collected for the two different crops with different potassium requirements but similar nitrogen and phosphorus requirements. Okay, then we will going to check its land requirements. Okay, lands yield. Okay, right here it is in the C1 format. Okay, and then it has been like the, wait a second, yes, right here you can see the graph. It has started with the 6 acre and then the peak of okay month wise 7, then the 8 lesser as it is showing the crops are removed, then the above and then the peak at again around the end of the month, which will be Rabi and Khabi crop growing season. Okay, means it has the same land cropping on the different type of lands, like different type of Rabi and Khabi on the different type of, like one is about to remove or other is about to start. Okay, then this graph show the distribution of crop yield. The graph has two smaller peaks which indicate the difference in the yield of two different crops on the same kind of soil. Now after reviewing this data across all of the columns, I have made some hypotheses such as different two crops in the dataset, relation between their crop yield and the other columns. Now I will test this hypothesis in the next session. Okay, then we have created a scatter graph. Okay, now let's run it to see it how it is working. Okay, right now we can see as the histograph is like it is going in this direction, so it will be the more sufficient part in the higher positive side. So from this we can see the rainfall and okay rainfall and yield. Then from this we can see the first cluster between the 400 to 500 ml and the second is above 1100 millimeter. This shows the that one crop has lower rainfall requirement and the other has the higher rainfall requirement. However, there is a still difference in the yield of crops which could be due to other factors as such as fertilizer, temperature, micronutrients, and most importantly the type of soil, which is right here. Okay, then we have taken the fertilizer and crop spectrograph for its okay. Right here, let's see it. Then we can take the right here, like this graph is also going in the upwards direction, which is the positive. Okay, then we can see is not directly completely showing the exactly behavior as the before graph, so it is not completely exactly having effect or the crop yield as an fertilizers used right here. Okay, so there are different data which is right here. You can see higher even when the fertilizer use is less than 65. This could indicate the type of soil. The micronutrients in the soil could be the reason for the high yield. Then okay, we have go to okay temperature and crop yield as again it's scatter plot. Yeah, it is showing the okay, as I can say Rabi and Krabi. Really an indication of it. Two different crops, winter and summer. Really an indication of it. Indication is coming. The key cluster between these two types 25 to 30 and 35 to 40. This could indicate that the dataset has been collected for different two crops. In the first cluster, the crop is higher than the second cluster. This could indicate the first cluster could be Rabi and the second as Krabi, like I have seen before, Rabi and Krabi right here. Then we will going to check its macronutrients parts, okay, with it as nitrogen, phosphorus and potassium with its yield. Okay, in okay, then we will going to take on next heat map part of it. Okay, so yes, right here you can see similar trend you can see in the graph, like they are similar as the has scatter graph, but it has right now showing the trend it is going. Okay, like nitrogen requirement is way more than phosphorus than potassium per square acre, like we can see the relationship. So right here, let's us read the stuff. We can see the hint of proportional relationship between the nutrients and the crop yield. The crop yield is higher when the nutrients are higher. The, this could indicate that the soil has less nutrients and the crop yield is less. However, still there are many data points which may deviate from the proportional relationship. This could be due to other miscellaneous factors as such as crop breed, soil type and weather conditions. So let's create a data map of this, sorry, heat map of it, this data set. So let's go. Okay, okay. Right here you can see it is the most higher part and then the that it is the higher it is. Okay, from the above EDM we can EDA or a exploratory data analysis, we can say that the data set has been collected from the two different crops. The data sets had two clusters for rainfall, temperature, and crop yield. There are the signs of proportional relationship between the crop nutrients and the crop yield. However, the relationship between the crop yield and the other column is not directly proportional. This could be due to other factors as soil type, weather conditions, and crop yield. Okay, then let's start the models part. Okay, right here we will going to split the test into the different part as it. We have taken the scale in model selection as the train split. Then we will going to take the X train, X test, Y train, and Y test. Okay, then let's just run it up. And right here it will going to show the four data frame will be okay. Then for the further, we have taken the models right here as the two decision tree regressor, random forest regressor. Okay, for its data set. For the faster and method, I have taken the random search CV, but it will reduce a little bit of an accuracy. So okay, be ready for it. If you have the higher powerful CPUs, then you can use the grid search, which is the way more accurate and requires a lot of time. Okay, for time management, I have used this. Okay, right now let's create the first model of us decision tree regressor. Okay, then we will going to run its normal module part. Okay, so guys, I have to skip the part of this whole part. So okay, for avoiding the weird time management. So right here we can see the hypertext turning by git search for your better accuracy. Right here I have taken it by managing the time. Right here you can see so the time here as you can further classify. Okay, that's why I have to skip it. So for the we have to clean the none values from the y train or x. So then we will going to take the prime grade as the maximum depth as this, then the sample split as this 2468, then sample leaf as this, and the random state 0 comma 42. Then we will going to estimate the grid search as the grid search library, then estimator as equal to ETR prime grade CV as 3 and job as this and the web rows. Then we will going to define its other part as the git search as fit x train clean and the y train clean. Then we will going to take its best parameters. Right here you can see its best parameters right here. It is coming, and right here you can see its full best parameter. Then we will going to get its best parameter and excluding the random state if it exists, then it will going to pop it by this command and we going to train the best version of it, this regression decision tree part, by writing the DRT is equal to decision tree researcher, okay, asterisk bracket asterisk asterisk best params and random states equal to 42. Then we will going to fit it in the X train clean and Y train clean. Then we will going to get its training score as, and it will going to then predict it. Okay, then it has been showing the training score as 0.93, which is a very good indication of this data happening. Okay, then we have taken the random forest researcher, and similarly we have taken the grid search right here, which is not recommended as it has taken the 70 minutes as according to my or system, and it is a very big data, so okay, you shall not always use this grid search. Okay, if you are lagging, then okay, you can switch to random one. Okay, then similarly we have taken the n estimated as 100, 200, 300, then max depth as 2468, then 2468, minimum as 2468, and then the similarly, and taken the older grid search option, and then taken it again in the format grid search fit x train clean and y clean and get its best parameter. Then we have trained the module with the best parameters, then we have fitted again for the best result of this, then printed training score, and right here it we can see it has the little better, which is the normally we can expect in any data set happening. Then we have a model evaluation part. We have taken the distribution plot of both of these as it will going to predict, check the predicted and actual part of both of the models we have created right here. Okay, and we have run it, and right here we can see as it is way more good in the density. Okay, then we have taken the evaluation merits, then again we have removed the key normal testing part, which will going to destroy us given an error. For the right here we have taken the mean square by writing here the mean square error as y test mass d for removing the n null values, then the repredict similarly, and the mean absolute error similar way like square, then again r score part of it, r2 square, which is basically for the accuracy. Okay, then we have taken the similarly with the rainforest part, right, you can see here. Okay, then we can see right here decision tree regressor as this 60, then 62 or 63 in approx 63.81, then 50 and 60, and then R2 score. Then we have taken the feature importance of it. In this we will going to ensure the rainforest is already trained, and then we will going to create a figure of it as we needing to install the both of the graphs right here, both of the regressor and this. Then feature df as pandas data frame features, then x columns and importance as feature importance of it. Then similarly with the other sorting part of it, importance ascending false and in place true, and then scat bar plot in the x as importance and y as feature. And similarly with the rainforest part, and we will going to show its graph. Okay, then we can see in the decision tree method, rainforest rainfall as maximum, in that put sm as this, this and this, and fertilizer as this. Okay, and in the rainforest as temperature as this and this and this. Okay, then in the conclusion we can say from the above analysis in the exploratory data analysis, it is clear that there are two crops in the data sets whose presence has been confirmed with two definite clusters in the graphs of rainfall, temperature and crop yield. The data set has been selected for two different crops. The data set has signs of proportional relationship between the nutrients and the crop yield. However, the relationship between the crop yield, the other column, is not directly proportional. This could be due to other factors like I had said before. And the coming to the machine learning models of it, I have used the here decision tree and random forest to crop. Random tree for a researcher as usual performs better than the decision tree researcher. The accuracy score of R2 score of it as 86 for 0.8649, and decision one as 0.8381. From the feature importance graph, we can see the temperature has the highest importance in predicting the crop yield. The temperature is followed by the rainfall. However, the micronutrients tend to have comparative less importance in predicting the crop yield. So thank you guys for watching this video. If you have any question regarding this project, make sure to comment in the end of the video so that I can answer it for your queries. Bye bye.